Okay, so now let's talk about trinomials. So we talked about graphing binomials and all of the crazy stuff about quadratics. We're still going to talk about a lot of those stuff, but now we're talking about an actual trinomial. So we keep the axis of symmetry formula, x equals negative b over 2a, and the vertex formula. We're going to use the y-intercept. Now the y-intercept is whenever x equals 0, and it's also always the c term. And then to find the symmetric point using the y-intercept, we take the number 2, multiply it to our axis of symmetry, comma, our c term. So hopefully this all meshes together well. Let's talk about number 1, first finding the axis of symmetry. So first let's label our a, b, and c. Our a term is 2, our b term is 4, and our c term is 3. So we're going to plug that into our axis of symmetry formula. I'm going to have negative 4 over 2 times 2. And then I get negative 4 on the top. 2 times 2 is 4. So negative 4 divided by 4 equals 1. Sorry, negative 1. So my axis of symmetry, so I get x equals negative 1, and that is my AOS. So I'm the type of person that likes to graph as I go. So I'm going to go to negative 1 on the x-axis, and I'm going to plot a dashed line vertical right through it. This is my AOS. Okay, so then for my vertex, I'm going to take my problem, which was my function, and instead of x, I'm going to write negative 1. So I get y equals 2 times, I'm going to put negative 1 in the parentheses, plus 4 times negative 1 inside the parentheses, plus 3. Trying to stick with my colors. Negative 1, negative 1. Then I'm going to just simplify from there. So I'll have y equals 2 times negative 1 squared. So negative 1 times negative 1, that's positive 1. Plus 4 times negative 1. Oh, that gives me negative 4. And then plus 3. Still using order of operations, 2 times 1 is 2, minus 4, plus 3. Gonna simplify from left to right. I get y equals negative 2 plus 3, and that's gonna give me y equals 1. So with my vertex, I have to combine my axis of symmetry and the point I just solved for my y. So my vertex is going to be negative 1, comma, positive 1 that I got for y. So let's plot that. I'm at negative 1, positive 1, so that right there is my vertex. Then my y-intercept. So my y-intercept is whenever x is 0, or it's just the c term, guys. It's so in front of your face that sometimes we miss it. So just for instance, I'm just going to do all this work and then you're going to see why. So 2 times 0 squared plus 4 times 0 plus 3. Well, 0 squared is 0, so I get 2 times 0 plus 4 times 0, which is 0, plus 3. 2 times 0 is 0 plus 3. Well, that gives me 3. So c term was 3. So why do all that work? It's just gonna be your c term. Don't do all the work. Save yourself some time. Let's just say that the y-intercept is at 0, 3. It's 0, comma c. Always. Okay, and our c term was 3. So we're gonna go to the y-intercept with 0, 3. I'm gonna plot my point. Now my symmetric point, I'm gonna keep the c term as my y. And I can do this either of two ways. I can use the axis of symmetry and I can say, oh, it's only 1 unit away from the axis of symmetry. Oh, it should be here. But if you don't see that, what you're going to do is you're going to take your axis of symmetry, which in this case was negative 1, and multiply it by 2. So negative 1 times 2, that gives you negative 2. So at negative 2, 3, oh, look at that. It is symmetric. It is 1 unit away. They are both 1 unit away. And that, my friends, is our parabola. Okay, let's get into the information about this parabola. So the domain, if you have not remembered, it is all real numbers. The range is wherever the y starts, so it starts at 1. So y is greater than or equal to 1. Number of solutions. Now this parabola never touches the x-axis, so there are no solutions. There's 0 solutions. So we're going to just write no solution here.